Hi, how are you? Last time we learned how to calculate surface area of some bodies. And then today, let's study how to calculate volume of the same bodies. Okay, so volume. The volume of a prism. Okay, the volume of a prism is equal to the area of the base times the height. Okay, so this is the base and this is the height. So the area of this base times this height is the volume of this prism. Okay, so this is the definition of volume. Okay, this is the definition of volume. So this is ruled by people. People say that we need to calculate volume this way. Okay, so the volume of a prism is equal to the area of the base times the height. Okay, so this is the first one, right? You learned this in grade 6, right? In grade 6. At latest, you learned this in grade 7, right? Okay, so either in grade 6 or in grade 7, you learned this. You know how to calculate the volume of a prism. Okay, then the second one, the second body we study is a pyramid. Okay, so the volume of a pyramid, this is a pyramid, right? A pyramid, you know the pyramids in Egypt, right? The Egyptian pyramids look like this, right? The base is a square, and then the slant area, the slant area is what? We'll say lateral faces or 4 triangles, right? 4 triangles, and then there is a tip. This tip is called a vertex, right? There is a vertex, so it is thinner and thinner, and then it comes to a tip, to a vertex. Okay, and there is a imaginary height. Okay, so you know this height. Height is a imaginary line segment starting from the vertex, and it goes down to the center of the base. Then that is the height, and the height is perpendicular with the base. Okay, is perpendicular with the base. Okay, so the volume of a pyramid is equal to the area of the base times the height. Okay, so it is first you can think about this. The area of the base times height. What is this? This is the volume of a prism, right? So a pyramid has only one third of the volume of a prism, right? Of the same height. If they are of the same height and they have they have equal bases. They have equal bases and they have the same height. Then a pyramid has only 1/3 of the volume, right, of a prism. Okay, so I put them together for you to compare, to contrast them. So now you know the similarities between a prism and a pyramid, and the difference, right? You know the difference. A pyramid is smaller, right? It is only 1/3, okay, of the volume of a prism. Okay, and they are similar, right? Most of the formula of this volume of a period is from the volume of the pyramid, from the prism, right? Okay. Then let's practice how to calculate the volume of a pyramid. Okay, so determine the volume of the pyramid-shaped container to the nearest cubic centimeter. Okay, so the formula is V equal to area of the base times height over 3, right? Okay, we'll say 1/3 of area of the base times height. Okay. Then let's identify the dimensions first, right? So for example, you need to get the area of the base, so you need to know the dimensions of the base, right? The base is a square. The base is a square, and the side is 8 centimeters long, right? 8 centimeters long everywhere. This one is 80 centimeters. This one is 8 centimeters. That is also 8 centimeters. This is also 8 centimeters. So you are able to calculate the base area, right? And then now you need to calculate. You need to know the height, right? Do you know the height? No, you don't know the height, right? You only know the slant height. Slant height means the, what does it mean? It means the length, the height of the slant triangle. The height of the slant triangle, you know it. The lateral triangle. Okay, you know this this height. Okay, but this cannot be used to calculate the volume, right? We need the height of the pyramid. So now you can imagine, right? Imagine the height there. Okay, so you draw a imaginary line segment. That is the height, and you connect this midpoint and the center of the base, right? Okay, so you know this is half, right? This is half. This is half of the dimension of the base, because this is also 4, so that is 4, right? So now you know this is 4 cm. Okay, and you know that slant height, which is 10 cm, right? You know this is 10 cm. So using Pythagorean theorem, you are able to calculate the height of this pyramid, right? Okay, the height of this pyramid, because this is a right triangle, right? Right triangle. I said this height is perpendicular with the bottom, right? Is perpendicular with the bottom. If this height is perpendicular with the bottom, then this height is perpendicular with any lines, any straight lines on the bottom. Okay, this 4 cm, this 4 cm dotted line is on the bottom, right? So it is perpendicular with the height. If they are perpendicular, then this is a 90-degree angle, right? If this is a 90-degree angle, then this is a right triangle, right? The dotted lines, this is 10 and this is 4 and the edge. So they make a right triangle. And this 10 cm is the hypotenuse, right? This one is the hypotenuse. Okay, so the 4 square plus h square is equal to 10 square, right? Okay, so h square plus 4 square is equal to 10 square. Okay, and then you solve for h, okay, because there is only one unknown, which is h, right? Okay, so this is 16 and this is 100. You move this 16 to the right side, so you get 84. So h square is equal to 84. So h is equal to square root of 84, right? This is about 9.2. Okay, so h is about 9.2. And then now you have everything you need, right? So the volume is equal to the formula. The formula is 1/3 of the base area. Base area is 8 square, right? 8 times 8, so 8 square times height. Height is 9.2, right? Okay, and then bring out your calculator, please. And with your calculator, you can get this answer. So it is almost equal to 196. Okay, so the volume is about 196 cubic centimeters. Okay, so answer, the volume is about 196 cubic centimeters. Okay, so we completed our answer to this problem. Then let's move on to the volume of a cylinder. The volume of a cylinder, you learned this in grade 8, right? In grade 8, you learned this. So it is defined, or say it's not defined actually. If it is compared with a prism, then it is similar to a prism, right? Okay, it is similar to a prism, so it is also, because everywhere the cross section of this cylinder, everywhere the cross section is the same, right? It is a circle. It is equal to the top. It is also equal to the bottom. Okay, so the bottom is the base, right? So this volume of a cylinder is also defined as the base area times height, right? Base area times its height. Okay, and the base area is the circle, right? Is the circle. The circle is pi r square, right? So pi r square is the base area times the height. So pi r square h is the formula of this the volume of this cylinder. Okay, you need to remember this, right? It's not hard to remember. Okay, to remain an excellent student, you need to remember all the formulas you encounter in high school. Okay, so the volume of a cylinder is equal to pi r square h. Okay, or say the base area times height. Okay, we do not practice for this one because we need to study cone. Okay, for a cylinder, you know its volume is area of base times height, right? How about the volume of a cone? The volume of a cone. So what is a cone? I do not explain this to you. Okay, I do not want to explain what a cone is. Okay, because you have eaten lots of conic ice cream, right? You have eaten lots of conic ice cream, so you know what a cone is, right? Actually, you are more familiar than I am with the cones. Okay, so the volume of a cone is actually like a cone compared to a cylinder is like a pyramid compared to a prism, right? Okay, so a cone also is sharp. It has a vertex, right? It has a tip, and it has a base. The base is a what? The base is a circle, and it has a imaginary height. The height is from the tip to the center of the base, right? The center of the bottom, and the height is perpendicular with the bottom. Okay, perpendicular with the bottom. So any line on the bottom, is perpendicular with the height. Okay. So the volume of a cone is equal to, still it is 1/3 of the area of the base times height, or say 1/3 of the volume of a cylinder. So if a cone has the same base with a cylinder, and they also have the same height, then the volume of a cone is 1/3 of that of the cylinder. Okay, because the area of base times height, this is the volume of a cylinder, right? And 1/3 of a cylinder is a cone, right? Okay, so 1/3 of a cylinder is a cone. Okay, the formula of the formula of the volume of a cone is just given to you, right? As well as the formula of the volume of a pyramid. Okay, they both have 1/3 in front of the parameters, right? The variables. In front of the variables, both of them have a one third there, right? Okay, and these formulas are only given to you, right? We now do not prove or derive. We do not derive the formulas for you, because to prove these formulas, you need integration of calculus. So in university you will study this. Okay. So now, for now, we do not prove it. We just bring out this formula, and then we use such formulas. Okay. Got it, right? The formula of a pyramid, the volume of a pyramid, the formula of a volume of a pyramid, and the formula for the volume of a cone. These two formulas are just given to you. They are not proved. If you want to prove them, you need to study calculus, the second part, integration first, and then you are able to prove the formulas. Okay. This formula we need to practice. Okay, so let's practice. Tracy makes her own frozen yogurt treats in cone-shaped paper cups. You have already used not millions, not thousands, at least hundreds, right? You have already used hundreds of such cone-shaped paper cups, right? Okay. Determine the volume of the frozen yogurt treat shown to the nearest cubic centimeter. Okay. So calculate the volume of this shape. Okay. So how do we calculate it? First, let's bring the formula. The formula V cone is equal to 1/3 of the volume of a cylinder. So it is 1/3 of pi r square h. What's a pi r square h over 3? Okay. So pi, we know this is a constant. We know this number. R, do we know it? Yeah, the radius, which is 4. So we know it. We know this number. How about the h? Yeah, h, we know it. It is 12, right? So we know everything, right? We know everything in the volume. We know all the variables. So let's bring the numbers into the variables. So 1/3, right? 1/3 a constant, pi a constant, r is 4, right? So 4 square times h is 12, right? So 12. Okay, so now we know all the numbers. So now use your calculator, please. Your calculator. So with your calculator, you can get such a result, right? So it is almost 201 or 201. Okay. So you can answer the volume of the frozen yogurt treat is approximately 201 cubic centimeters. Okay. Here it says you can estimate the answer without using a calculator. Okay. If you do not have a calculator, then you can estimate it very quickly, because the pi is 3.14, right? 3.14. 3.14 is almost equal to 3, right? So it is close to 3. So you can just use 3 to estimate, right? You can use 3 as pi to estimate your answer. Okay, so if you bring 3 to here, so 3 and 3 cancelled, right? 3 and 3 can be cancelled. So these two numbers can go, right? If they go, then only these two numbers are left behind, right? So 4 square is 16. 16 times 12, so it is 192, right? 192. So 192 is close to 200, right? 192 is close to 200. So this estimate is not wrong, but it has a little error, right? Error means the difference between your estimated number and the true number. Okay, so the difference, there is a little difference, right? So that's area, not a mistake, not wrong. Okay. I mean in the wilderness, if you do not carry a calculator, right? So you can estimate your answer. Okay, you can if you estimate your answer, then you can use this easy method, right? Okay. Then what is this? This is to review, to summarize the things we learned today. Okay. So what is it? It is this. You compare a prism with your pyramid, and you compare your cylinder with your cone. Okay. This pyramid, this prism and this pyramid, they have the same base. They have equal bases, and they have equal height. Okay. But the volume of this one is just one third of this one. So if you if this is a container, then you hold one third of the container. You hold, for example, water that occupies just one third of the volume, the capacity, one third of the capacity, and then you transfer the water into this pyramid shaped container. Then it will be full. Okay. This is also the same situation, right? If this cone and this cylinder, they have the same, or they have equal bases. They have the same base, or they have equal bases, and they have equal height. Okay. So now the volume of this cone is just one third of that of this cylinder. Okay. So if this cylinder is a container and this cone is also a container, then for example, you hold some water. The volume of the water is just one third of the capacity of this container. Then now you can transfer the water into this cone, and then the cone will become full. Okay. So that is we use some story to help you to remember the formulas of the pyramid, and the volume of the pyramid, and the formula of the volume of a cone. Okay. You need to remember them, because I know you want to remain excellent, right? I know you want to remain excellent. To remain an excellent student, you need to remember all the formulas you encounter in high school. Okay. So please do it. It's not hard. Okay. Because I did it when I was young. Okay. The volume of a ball, was a sphere. A sphere is a ball, right? Okay. So now let's calculate the volume of a ball. So what is the formula? The formula is also just given to you. It is just given to you. It's not proved here. It's not proved here. I mean, in grade 9. If you want to prove it, then do it when you are in university. Okay. After you have studied integration, the second part of calculus. Okay. So the volume of a sphere is equal to 4/3 pi r cubic. Okay. 4/3 pi r cubic. Okay. So you read many times, then you can remember it. Okay. After you have remembered it, let's practice. Okay. Let's solve a problem. Okay. So this example, volume of Pluto. Pluto was not easy. Okay. Pluto was the smallest planet in the solar system. Now it is not a planet anymore. It is kicked out of the family of the planets. Now there are only 8 planets in the solar system, right? Previously, half a century ago, there were 9, including Pluto. But now Pluto is a dwarf planet, right? Pluto is a dwarf planet in the solar system. Okay. If we say when when it was a planet in the solar system, it was the smallest. Okay, it was the smallest one. Okay, smallest one. Okay. The diameter of the Pluto is approximately 2,290 kilometers. Calculate the volume of Pluto. Okay, let's do it. Just use the formula, right? So use the formula of the volume of a sphere, the volume of a sphere, or say a ball. Okay, so it is equal to 4/3 pi r cubic, right? Okay, 4/3 is a constant number. We know it. Pi constant, we know it. So we only need to know r, right? We only need to know r. So do we know r? Are we giving r? We are giving a number. Okay, this number, but this number is a diameter. The diameter, right? It is diameter, not radius. So we need to do a simple calculation, right? We need to do simple calculation. Okay, the radius is 1/2 of the diameter. Okay, so let's divide this number by 2. So it is 1145, right? So it is 1145 kilometer. Okay, so the radius of Pluto is 1145 kilometers. Okay, so let's use kilometer as our unit, right? Okay, because if we use meter, then the number is too large, too inconvenient, too uncomfortable. Okay, so bring this number into the r, right? Into the r. Okay, so now it is 4/3 pi times this number cubic. So this is a huge number, and I cannot do it in my mind. So I need to do it with a calculator, or say on paper. But if I do it on paper with a pencil, then it takes about 2 minutes or 3 minutes, right? But if I use a calculator, then it takes me 10 seconds or 5 seconds. Okay, so now you use your calculator, please, and then you can get such a answer, right? So it is 369. Okay, so 9 zeros, right? So to here it is 1,000, to here it is million, and then to here it is billion, right? So 6.3 billion, right? 6.3 billion, or say about 6 billion. So about 6 billion. So the volume of Pluto is approximately 6.3 billion cubic kilometers. 1 cubic kilometer is already very huge, right? It is how huge? It is thousands of, or actually millions. Yeah, millions of buildings, right? Houses. If you say houses, then millions of houses. If you say condo buildings, then thousands, right? 1 cubic kilometer is thousands of condo buildings. Then how about 6.3 billion such mountains? Okay. So this means this sphere, this Pluto, this smallest planet is really very, very huge, right? Okay. Just like our Earth, the Earth is also very huge, right? If compared to the size of yourself, then the Earth is the world is very, very huge. Okay. So this is the end of our study of today. Okay. So thank you. Good luck. Okay. This is easy, right? Okay. This is almost the end of this grade 9 maths. Okay. So I wish you good luck. Okay. Thank you. And I believe you can get a high mark in your final exam. Okay. Thank you. Bye.